All right, here we go. Hello, everyone. Welcome to Skype a Scientist Live. Today, we're going to be talking all about volcanoes with scientist Dr. Samuel Mitchell. Today, as you probably know, this is a question and answer session in addition to an intro from Sam. So if you have questions, and we hope you do, please submit them to the Q&A session or section at the bottom. We will get through as many as we possibly can over the next 45 minutes. If you're watching on YouTube right now, or you're watching live with us in the Zoom, we can match you with a scientist just for your class, for your club, for your scout troop, for your library, whenever you want. We've got over 1,000 scientists to choose from. We can get you matched with a scientist from over 35 categories of science, totally for free. We match once a week. Go to skypeascientist.com, click sign up, and then you can get a match just for you. But without any further ado, let's talk about volcanoes. Sam, thank you so much for joining us.
Absolutely. Happy to be here. So yeah, thank you for inviting me, Sarah, and to the rest of the Skype scientist team for setting this up. And hello to everybody who's watching wherever in the world you are, whatever time it is for you, however old you are, wherever you may be. Volcanoes are something that we find all over the world, and you may find them in your country, you may live close to one, you might be very far away from one. You might have even seen one in person, maybe on vacation, or maybe you've seen them in a book, or maybe on a TV documentary or a movie. But there's something that we find all over the world. And I'm happy to take all of your questions, but I'm just going to give you a couple of teasers before we get into it, particularly about volcanoes in weird and wonderful places. But a little bit about me as well. I don't like to speak a lot about me because the cool stuff is the volcanoes, but also there are people who have to study them. So, first of all, just kind of a bit of an intro to myself. So, my name's Sam Mitchell. I'm based in the UK, so I'm calling you from England right now. So, I am a geologist, a volcano scientist, or what we also call a volcanologist. But I'm also a marine scientist as well. So, I kind of cover a bit of everything all across Earth science, and basically, I've always wanted to understand how the planet works. I've always been fascinated by the things that go on our planet, the things that come out of it, the things at the bottom of our oceans. But my specialty that I went down into for my education was all about volcanoes. So after finishing school, I went and did a degree in geology. So I studied geology at university and earth science. But during that, I also found a love for the oceans. And so I also found a love for volcanoes. I'd always kind of wanted to do volcanoes. And then from there, I went and did a PhD. So I became a doctor in geology and geophysics, but my specialty was volcanoes in the oceans. So I managed to bring together the two things that I actually found a real love for. So in doing so, I've been able to travel all over the world studying volcanoes on land, but also in the oceans as well. And it's something you might be able to ask me about a bit later, but I've also spent some time in a submarine studying volcanoes at the bottom of the ocean. So I'm happy to answer any questions about what diving in a submarine is like as well. But as well as being a geologist and volcano scientist, I also do things that a lot of the folks that come on Skype Scientists do, which is being a science communicator. So what Sarah does as well. So communicating our science to the general public and helping you fall in love with this subject as much as I do. Something else that I also do as part of my job, I'm also an expedition guide. So I go to extreme regions of the world, mainly Antarctica, and I guide other people around those regions. So I teach them about the geology, about the landscapes, what's going on in the water, about the ice. And as you see from one of those pictures there, there's a couple of penguins in the background and also a seal. So it comes with the benefits of seeing a bit of wildlife. So there's some amazing perks about being a geologist or earth scientist, marine scientist, and it all covers these little things at the bottom of the slide there. You get to go and do field work. You get to work with samples from amazing places around the world. It allows you to travel and also to work with an amazing group of people who all just love nature. So everybody that you meet is normally has this incredible passion about the world itself. So, a little bit about me. This might answer some of your early questions already, but again, happy to answer any more. What is a volcanologist? So, a volcanologist is essentially someone who studies volcanoes. Now, these pictures are the more extreme end of things, and not all volcanologists will actually be standing there on a rope dangling over a boiling lake of lava. But the pictures you see up towards the top are volcano scientists who work at a volcano observatory. So they are monitoring volcanoes. Most of those pictures at the top are actually from Kilauea on the island of Hawaii. So these are scientists working at the Hawaii Volcano Observatory and making sure we understand everything we know about volcanoes. But sometimes volcano scientists are also based at universities. They're working on samples from field work. They're collecting things. They're collecting data, or they might be teaching classes about geology. So there's many different things that come under the umbrella of being a volcano scientist. It doesn't mean you're always in the field or you're always in the lab looking at samples. There can be a bit of a mixture. So there are volcanoes all over the world. This map, everywhere you see either a circle or a triangle, there are volcanoes scattered everywhere. So take a look at this map for a second, wherever you may be in the world, or maybe other places you're interested in, and think and have a look at where some of the volcanoes are. The triangles that you see are volcanoes that have actually erupted since the 1800s, so in the last 200 years or so. And then all the circles are other known volcanoes. Now, one of the things that might surprise you about that map is that a lot of them are actually in the oceans. And one of the cool facts about volcano science is that there are actually more volcanoes in the oceans than there are on land. About 80%. So if you were to have 10 volcanoes around the world, eight of those would actually be in our oceans. But there are many, many more volcanoes in our oceans than there are on land. So if that's something you didn't know before, you can take that one away with you. So where do we actually find volcanoes? We've kind of said we find them all over the world, and because we can find them all over the world, we can find them in really strange and wonderful places. So I've given you just a couple of examples on this slide here to show you the variety of where volcanoes can be. In the very top left-hand corner, we have Mount Vesuvius, which is in Italy, and that is surrounded by the city of Naples. If you've ever heard of Pompeii, this is that volcano, and that's where it is. So today, it's not a small Roman town, it's surrounded by a huge city. If we keep going around the top, you've got a volcano in the middle of a jungle. So you can have volcanoes in tropical regions. You can have volcanoes as tiny islands in the middle of the ocean. You can have volcanoes that are in very cold places or deserts. We can see one in the bottom there with a llama at the bottom. So those are volcanoes out in towards the Atacama Desert region, out towards Chile and Peru. You can have very high volcanoes, so they're covered in snow. I've already said you can have volcanoes in the bottom of the oceans. That photo in the bottom in the middle is a volcano erupting underwater and it's being captured by a submarine on camera. And then my two personal favorites, even though I study volcanoes in the oceans, you've got volcanoes in Antarctica. So there's actually a penguin colony that lives at the base of a volcano in Antarctica. And then you can also have volcanoes on other planets as well. This example here being Mars. Ooh, that one hasn't worked. So, like I said before, we do have actually volcanoes in our oceans as well. So, one of the things that I do as a scientist is I go on research expeditions, and so we go out on a ship out to sea, and we send materials and technology down to the seafloor to try and understand why volcanoes are erupting in our oceans, and are they actually a danger to us? So, this picture here is actually of an underwater submarine, or what we would call a submersible, and there's no one inside this one. It's actually remotely controlled from the ship, but we can send these down and it allows you to basically sample things down at the bottom of a volcano, which is very, very cool. And this is just a couple of those images as an example of what volcanoes look like erupting at the bottom of the ocean. So these are actually very, very small. These aren't your huge explosions that produce huge clouds of gas that may cover an entire area. They're relatively small. You could probably fit these explosions inside of your house. But because they're quite small, it means that the submersible, the submarine, was able to get close enough to actually take a photo. So these are the only two examples we have on camera of actually volcanoes erupting in our oceans. We have thousands and thousands of hours of footage of volcanoes erupting on land, but there's only actually two instances where we've recorded them in the oceans, which is really quite incredible. So, unfortunately, a couple of the slides went a little blank, but that's okay. So one thing I want to kind of leave you with a thought is everything about volcanoes bad? Because volcanoes are shown for their destructive power, the way that lava can destroy things, or clouds of gas that may, say, destroy cities or be dangerous. But there's actually some benefits to volcanoes as well. We owe our land to volcanoes erupting. Uh, Around the world is divided into tectonic plates. These are areas where the world has been split up into plates that move around. So this is the ground beneath us. So you have the North American plate, you have the South American plate, the Eurasian, the African plate. They're almost like our continents, but they move around and they pass against each other. And where those plates meet is actually where you get destructive volcanic activity. But it also makes land. So some of the benefits about volcanoes, first of all, they're incredible to see. They are incredible sources of beauty and nature and awe and wonder, and so people go to see them when it's safe. If you get safe volcanoes to go to, you can actually have tourism. The ash from volcanoes is also really good at making fertile soil. So there are many places around the world where the soil is really good to grow on because of volcanic ash. It's got lots of chemicals and nutrients that make the soil very good for plants to grow. Another great thing about volcanoes is they can also supply the basis for coral reefs. If you have volcanic islands in the middle of the ocean, over time they start to break away and slowly go down. And during that time, you can make coral reefs around these volcanoes. So you'll see these on a lot of tropical islands around the world. So, like I say, there are many, many different ways that volcanoes can actually teach us about our planet. There are also incredible things to see. There can be sources of life and wildlife and plants and incredible nature. So, it's just something to remember. Even though volcanoes can be destructive, they can also create amazing things as well. So, hopefully, that's just given you a bit of a teaser and maybe even fueled some questions for you. So, I'll leave you with one of my favorite photos that's ever been captured from a volcano, which is actually from one of the lava lakes on Hawaii in the past, where it produced a nice little smiley face. I've got some other slides I could maybe show, but I'm happy to answer any questions you might have about being a volcanologist, being a geologist, what it's like to go into the field, anything you might want to ask.
All right, sounds good. We could already have 55 questions. So let's get into it.
Let's do
Um,
it.
all right, Toller Elementary fifth grade in San Diego asks, what is the most dangerous volcano that you've ever visited?
Most dangerous volcano I've ever visited. In terms of my personal danger from visiting it, so I have worked on the edge of a lava lake like this. So a lava lake is basically an open window into a volcano, and there is just lava in the base of it. And I have done field work standing at the edge of one of those. So you can literally look over and you are basically looking right down into lava just beneath your feet. And that was on Kilauea volcano on the island of Hawaii.
That's so cool. That's so wild. I can't believe in some of those pictures, people were looked to be very, very close to the lava.
Yes.
I
The,
mean, those suits, how are they protecting you against something that destructive?
I think some of those photos are also got some clever perception
Yeah.
focus
Okay.
going on. So sometimes that lava may not be quite as close as it looks, but the suits provide some protection from heat, but they won't provide you protection from the actual material itself. So these
Right.
folks who go and do like this extreme volcano adventuring, scientists don't have necessarily a need to go that close, particularly in the silver suits, but it does protect you from the insane amount of heat that comes off of the lava. But if a lava, as we would call them, lava bombs that erupt out of a volcano, if one of those is coming towards you, there's only so much a silver suit can do.
Right, for sure. Yeah, wild. Yeah, something we talk about a lot in deep sea science is that, you see these often like super wealthy people going in submarines down to the bottom of the ocean, whereas a lot of the scientists are like, we can actually get everything done just by sending a robot. Like we don't have to send a
Yes.
person there. Yeah, so it's like there's the pictures that come from people who want to go on an adventure, um, and then the people who actually want to get data, and it's like those things don't always line up. It's kind of interesting to see. The Discovery Channel
Yeah.
is the lab. Yeah.
Yeah, there's a variety of different ways that we can get down to the seafloor in these kinds of submersibles or submarines, and they used to be more people focused. So it used to be a
Yeah.
small space for a couple of scientists and a pilot to go down in the submarine. But when you fit people inside, you have to take up space
Yeah.
for that. And that usually means you have to give up certain pieces of equipment. So nowadays, submersibles are actually more remotely controlled from the scientists on the ship.
Hmm.
And so that allows more technology inside the submersible, and it also makes it a lot safer. But I think there's something to say for humans still experiencing that.
Yeah. Very cool.
But yeah.
All right, we got a question from Renfro, fourth grade. When a volcano erupts underwater, are animals able to sense it and get away beforehand, or are they caught unaware?
Oh, that's an amazing question. So there's lots of different signals that volcanoes give us that they're maybe about to erupt, or well, if they are erupting, the clear sign is there's lava coming out of the ground. But movement of magma in the earth means the way magma moves is it has to break the rock around it. So normally there are always earthquakes that accompany when a volcano is erupting. So, and there's lots of them. It's not just like one big magnitude 6, 7, 8 earthquake. Normally they're very, very small, so magnitude 2 or 3, but there will be hundreds and thousands of them as that magma is coming towards the surface. So earthquakes are a really good sign. So earthquakes will disturb the water. They will create vibrations in the water, which is a disturbance to wildlife. You may also get gases escaping out of the ground before the magma arrives. So you're going to change the chemistry of the seawater because volcanoes pump out sulfur, carbon dioxide, chlorine, fluorine, a whole range of metals as well. So it messes with the chemistry, and that's going to tell animals to get out. As
Right.
well as heat, you can get local heating. So, like I said, there's all these little warning signs on land and in the water that volcanoes might be about to erupt.
And is that similar? We've got another question from B. Miller. How do scientists know when volcanoes are going to erupt? So is it similar? Like we're looking for gases, we're looking for vibrations. Like what are the sensors that we have out there?
Yeah, exactly. So it's a lot more challenging underwater. So I'll say that for start. It's a lot more challenging. It's a lot more expensive because you have to put all of that equipment down on the seafloor, and then you also have to get the data off of your instruments.
Right.
But what classically happens on land is we have seismometers. So these are measuring earthquakes. So say you have a perfect volcano, and around it are maybe 10 seismometers that are all listening for earthquakes that might happen. So those seismometers will see how deep the earthquakes are, how many there are, how big they are, and they'll track those over time. So we look for patterns in how the earthquakes are they getting bigger? Are the earthquakes getting shallower, meaning the magma might be getting shallower? So earthquakes are probably one of the best ways we detect. Also, volcanoes I'd say they're alive. They breathe in cycles because they're full of liquid and gas, and you're pumping magma from deep in the ground to somewhere shallow. They actually inflate before they erupt, not, miles and miles above the surface of the ground. They're literally inflating on scales of millimeters, centimeters, inches, tiny, tiny amounts. So what we have are special GPS stations, like you would have in your car or that satellites would use to measure the ground. These GPS stations can measure really tiny changes in the Earth's surface. And so that means we can detect when volcanoes are inflating. And usually inflating means there is magma building up under the ground. Like I said before as well, you can have gas sensors. If you've got water, so say you've got a lake nearby a volcano, you could look for changes in the lake chemistry. You could look for changes in the lake temperature as well. So there's probably about five or six different ways that we use to detect if volcanoes might be erupting.
Very cool. Thank you. We have a couple people asking questions about volcanoes on other planets, and a lot of people asking about volcanoes on Mars. Like, how similar are these, and like, can they exist other places?
Absolutely. So I'm glad, whether that was spurred on by me teasing that or somebody already had that question. If you already had that question, fantastic. And so there are absolutely volcanoes on other planets. Essentially, anywhere you have a planet or a moon that has a semi-molten hot liquid rock mixture on the inside, that mixture, magma, will want to get out and it will want to escape. So wherever you have a solid crust and a hot, as we call it, mantle underneath, you will have magma that wants to escape out the ground. So we have volcanoes on Mars. We have volcanoes on the planet Venus. Venus, we actually think might still be volcanically active. It's very difficult with Venus because the whole planet is covered in a thick cloud of carbon dioxide, so we can't see the surface of Venus. It's also incredibly hot. It's over 1,000 degrees Fahrenheit on the surface of Venus. It's very, very difficult to get things down there to see what's happening. But the volcanoes on Mars, for example, are very different to Earth. As I said before, Earth is split up into lots of continents and these tectonic plates that move around. Mars doesn't have any of that. So what it means is the volcanoes don't move around with the continents, so they stay fixed. So the volcanoes build up in just a couple of places. So there's only really a dozen or so volcanoes you would see on the surface of Mars. But because of that, they just build and build and build and build over time. And that means we have the largest volcano in the solar system on Mars. That's Olympus Mons, and it's 2.5 times the height of Mount Everest. And it's as wide as the state of Arizona on its base, or also the country of France.
Wow, huge.
Yeah,
Cool.
so Venus has lots of volcanoes. Like we say, we think it might still be active, but it's very difficult to see it from the surface. But we're sending a few missions to Venus, hopefully in the coming years, that will find more out about that. And then if you go even further away from our local, so those are our local planets, Venus and Mars, some of the moons of Jupiter and of Saturn are also erupting magma. I'm putting magma in little quotes here because it's not liquid rock like we have here on Earth, Venus, and Mars. It's actually water. So the insides of these moons are liquid water that erupts out of a shell of ice. So they're what we would call cryovolcanoes, which means ice volcanoes. So they're volcanoes that erupt out water.
Cool. Very cool.
It's a
Um,
cool area of science. I wish I did
yeah.
more of it myself.
Wow, neat. So a couple people asked, what are the specific questions that you are trying to answer about volcanoes in your work?
Yeah, so I've studied a mixture of volcanoes on land and in the ocean, but like I said earlier on, my focus has been volcanoes in the oceans, and that's purely down to I chose a project for my PhD for when I did my doctor that involved studying volcanoes and also the chance to do some ocean science. So I became really fascinated by how volcanoes erupt underwater, and particularly how they erupt differently to volcanoes on land, or in some cases similar. Volcanoes deep in the ocean do not really pose a danger to us. If they're erupting 2, 3 miles down in our ocean, that material is not coming to the surface, it's not coming onto land. They're incredibly fascinating to study because they're under extreme pressures. Gas doesn't erupt as gas as we know it. So normally gas boils at a certain temperature. It boils much, much higher at the bottom of the ocean. So the chemistry and the physics is all really strange. So it's a fascinating thing to study. But for studying shallow volcanoes, so these are volcanoes maybe only just under a few tens of meters of water that might be very close to the surface or maybe just offshore. We need to study those because it's still hard to monitor them. It's still hard to put any equipment on volcanoes in the water. You have to do a research expedition on a ship. But those volcanoes have the ability to erupt out of the water and cause impacts on land. So one of the things I'm particularly interested in is how we can improve how we can improve understanding those shallow volcanoes and
Cool.
how they erupt.
Awesome. Very interesting. We've got a really fun question from Michelle. Does lava come in different colors?
Oh, that is a wonderful question because it hits one of my favorite volcanoes on the planet. So, lava can absolutely come in different colors. Most of the time, the color of lava is due to how hot it is. So this is something in science we call incandescence. And incandescence essentially means it is so hot that it is giving off a radiation that is also giving color. So just like in this picture, you still see the bright spots are where it is hotter. So even though we might think red is fire, and so red means hot. Actually, the brighter that color is, so the more it goes orange, yellow, even possibly appearing white, it means it is hotter. The hottest, this goes into astronomy, but the hottest stars in our solar system, in our galaxy, in our uni not in our solar system, in our galaxy, in our universe, the hottest stars are actually blue. Blue is the hottest color. Um, but there's actually one volcano in Africa called Oldonyo Lengai, which erupts a very, very strange type of magma, and it's really rich in something we call calcium carbonate, or as you might know it, chalk. So
Oh,
it's almost like hot liquid chalk that erupts out of this volcano. But it's not quite as hot as normal magma, so it doesn't glow. It doesn't have that fiery red, orange, yellow glow. So when it erupts out, it's got the thickness of water, just like in this glass. So it's this runny, but it's jet black and it doesn't glow. But because then it's made of chalk, when it cools down, it turns white.
that's so cool.
So normally when lava cools down, just like in this picture, it turns black. In
Right.
this case, it's a runny black lava that turns white when it cools down.
Huh. Weird.
So
Cool.
that, yeah, lots of colors.
Great. Could we stop sharing screen so that the
Of,
ASL interpreter is a little bit bigger?
oh, of
Um,
course.
that would be great. Thank you. Okay.
No problem.
Our next question, we had a couple questions all kind of around whether volcanoes on land explode differently than the ones underwater. Like, does the pressure in the deep sea affect this? Does the temperature in places either underwater or like in Antarctica, does the temperature and pressure affect how explosive a volcano can be?
Absolutely. And this is literally the question that I was tasked with understanding for my PhD was, do volcanoes erupt explosively different underwater than they do on land? Because the main thing you have in water is pressure. Whenever you have something on top of something else, you're pushing down on it. So you're adding pressure to the surface. So in the water, for example, if you go 100 meters deep, the pressure is 10 times what you're feeling right now. If you go 1,000 meters deep in the ocean, so 1 kilometer, the pressure is 100 times what we experience on land. And what that means for volcanoes is it's harder for it to erupt explosively. If you imagine a bottle of Coca-Cola, if you shake up a bottle of Coca-Cola with the lid still on, nothing will happen because that liquid has been put in under high pressure. The second you take off that cap, what does it do? All the bubbles rush out and it explodes. And that's because you've suddenly released all of that pressure. And so that's kind of how a volcano works, essentially. The magma's under high pressure under the ground, and you have all of this gas dissolved in the liquid. And when you release that pressure, all of those gas bubbles form and it drives the explosion of the magma out of the ground. But in the ocean, because you already have lots of high pressure, it means that those bubbles can't escape. The bubbles can't grow and they can't drive the magma easily out of the ground. So it means that it's harder for them to explode.
Cool. That makes sense. Great. Thank you.
As a little follow-up on it, because someone asked about, say, Antarctica, the same is for ice. So you can have volcanoes under glaciers, you can have volcanoes covered in ice, and that's another big question we're looking at in volcano history, is how has the changing of, say, the polar ice caps or the changing of glaciers affected how volcanoes erupt over time. So as you lose ice, let's take Iceland, for example. There are
Mhm.
many volcanoes on Iceland, and a lot of them are covered by the big ice caps. But if
Mhm.
those ice caps are melting, is it more likely that volcanoes will erupt? So it's a
Oh,
very big question at the moment.
right. Huh. Good. Another reason climate change can freak us out. We'll add that
There
to the
we go.
laundry
Yeah.
list of reasons.
Like I
Yikes.
said, it's a question.
We don't know. Okay,
Yeah,
maybe we should add it to the list of
yeah.
anxieties. Good.
Yeah.
Wonderful. We've had this question from a bunch of different classes, including Mrs. Brill's fourth grade class. Um, have you ever been hurt doing this? Like, is volcanology a more dangerous type of science than a cell and molecular biologist or any other thing?
I don't know. I almost feel like a molecular biologist might come into a
Yes,
closer,
but sometimes we get into stuff that could mess with our DNA. You don't want to like
yeah,
eat
closer
it by
contact.
accident. Yeah.
At least the things we're dealing with in volcanology are very visual and they're very big.
Right. Right.
And so, like, you can see the danger, and the danger
Yeah.
is coming towards you.
Right.
Um, but kind of what I said towards the beginning when I was talking about what is a volcanologist.
Hmm.
You can choose to not be a field volcanologist if you don't want to. Lots of volcanologists I know, they actually do more of the physics and the math behind how these things work. So they're doing a lot of lab work or maybe computer modeling. So if you actually are really fascinated by volcanoes, but you don't actually want to be outdoors, there's lots of options for you. So a lot of my work is based in the lab, usually working on samples I've collected in field work. Um, but it becomes more dangerous, I'd say, if you are a volcanologist working at one of these volcano observatories. Say for the United States Geological Survey,
Hmm.
working at the Hawaii Volcano Observatory, where your job is to go out to the volcano on a daily basis. Normally, you're taking, images from a camera or you're collecting instrument data. Um, you're not always coming into close contact with the eruptions and the danger. So it can be a safe subject. You don't have to go and stand next to lava if you want to be a volcanologist.
Cool. Sounds good. Multiple people have asked, like, where does the heat come from? Like, why is lava hot?
Mm,
Effectively is the question.
yeah. So to answer that, we just actually have to look at the planet as a whole. The outside of our planet is relatively cool, but what if you were just if we would let's dig a hole all the way from the surface right to the center of the Earth. As you go through the skin of it, literally the crust of our planet is like the skin of an apple. It's so, so thin compared to everything else that's underneath. So what we live on is literally that skin of the apple. If we break away that skin, the temperature is increasing and increasing and increasing the further we go down. Because when you apply pressure to something, you also heat it up because those molecules are getting closer together, all those atoms, and there's lots of energy between molecules. So the more compressed things get, the hotter they get. So that's one reason the pressure is adding temperature. Also, things always stay hot on the inside and they cool to their outside. So our planet, when it was forming, was rocks colliding together and building up over millions and millions of years. And where all of those collisions were happening in the center, it became very, very hot because of all that crashing. But as the planet grew and grew and grew and grew and grew, the interior has stayed hot for 4.5 billion years, which is why our core, our inner core, is still a solid ball of iron, but it's at incredible pressure, but it's at temperatures of, I'm trying to do my Fahrenheit conversion here, but 4,000, 5,000 degrees Celsius. So the center of our planet is the temperature of the surface of the sun. And it
Wow.
is taking so long for that to cool down, literally billions of years, that it means there is incredible heat still within our planet. So
Mhm.
that heat in magma, even though the magma is right at the surface, it's basically the remaining heat that's slowly working its way out from the Earth's core.
Wild.
The other reason why there's heat is because there's radioactive elements within magma that decay. And when radioactive elements decay, they give off heat. So potassium is one of those sources in. So potassium is actually not. it's slightly radioactive,
Right.
but
Like
on a
bananas are a little radioactive.
exactly, yeah. I don't
Yeah.
want people to look at their bananas in their fruit bowl and think I can't eat those; they're radioactive.
Right,
But
right.
they do actually give off some radioactive energy, and that produces some heat, and so that's the same in magma.
Cool. Many people have asked, what originally got you interested in volcanology?
hmm So I got interested in this subject when I was 11 years old. Exactly. So before that, I wanted to be a music teacher.
Okay.
My career aspirations at 11 years old were to be an English and a music teacher, I think specifically in my high school
Uh-huh. Yeah, yeah.
or my middle school at the time. Um, but then happened an event on the news, and this was the 2004 Indonesian tsunami. So this was a big, very, very large natural disaster that occurred in 2004, so 20 over 20 years ago. And there was a giant tsunami in the Indian Ocean that sadly killed over 200,000 people. But that tsunami was caused because of a giant earthquake
Hmm.
around Indonesia. And this was just all over the news at the time. You may remember as well. It was just everywhere. You couldn't
Oh, yeah.
escape this incredible event. And I just remember sitting there and being fascinated by the power that went into this event. So it
Right.
wasn't actually like a moment of deciding I wanted to study volcanoes for the rest of my life, but I wanted to study the power of nature and natural hazards. So they all come under that bracket, earthquakes and tsunamis, volcanoes. And just by going to the library and picking out some books, I ended up finding, oh, actually, there's red stuff that comes out of the mountains in the ground.
Yeah.
And
Very
so
cool.
what I took out lots of books from the library, but I got one book in particular, and it's right here behind me on my bookshelf, and it's just called Earth. And so that is a big chunky book. It's about 500 pages, and it's just everything about earth science. So that's all I did. I saw something on the news. I was interested in it, and then I followed that through middle school and high school. I was fascinated by geography. The nice thing about geology is it's got a bit of geography, a bit of chemistry, some physics, a bit of biology, and then also some history in
Yeah.
there as well. So it's really fascinating multi-subject.
Very cool. I also got inspired by a library thing. I mean, not news then library, but was going to
Yeah.
the library a lot. Got a videotape about the ocean, saw cuttlefish, and that was pretty much it.
So
So
there you go, folks.
libraries,
Do not underestimate the power of your little local library going
so
in
true.
and just seeing what books, what cover takes your eye, makes you think, oh, that looks interesting,
Yeah.
because you never know what you might find on the inside.
Exactly. So true. We got Mayo Elementary second graders that want to know, do you have like a favorite volcano or is there like a dream volcano that you'd love to be able to study?
Okay, so I won't well, the one in Tanzania in Africa that erupts the runny black lava that
Yeah.
turns into white chalk. That's definitely up there. But I've already spoken about that one, so we'll leave that one on standby. And another one I would love to be able to go and see or study. Ooh, I'm trying to think where I would want to go. Oh, I know. So the USA actually has the most volcanoes of any country in the world, which is always a really surprising fact for people. They think it might be somewhere like Italy or Japan or maybe Indonesia, but it's
Hmm.
actually the USA. So your mind would immediately go to the Cascades, to
Hmm.
Mount St. Helens, all these Mount St. Helens, Mount Hood, Mount Baker, Mount Rainier, these volcanoes that run through Washington and Oregon and down into California. But actually the majority of them are in Alaska.
Hmm.
And they're in the Aleutian Islands that come off
Uh-huh.
of the bottom left-hand corner, and it's just a chain of islands that actually go all the way to eastern Russia. And those are the Aleutian Islands, and that entire arc of islands, they're all volcanoes. So that's why the USA has the most volcanoes, and there are some incredible ones over there. So there's one called Mount Cleveland,
Mhm.
which is your perfect. It's the perfect triangle. Nice little snow-covered top, little hole crater at the top, and it's just one island. And then there's another one which has a fantastic name called Okmok.
Oh.
OK, Okmok. But yeah, they're very difficult to get to. You have to fly out by helicopter to even access them. So
Mhm.
it's an adventure going to
Really
those
cool.
volcanoes.
Wow. I was expecting you to say Hawaii and
Oh,
went
okay,
Alaska. Wow.
okay.
Very cool.
Hawaii volcanoes have a place in my heart because I lived there as well for 3 years.
Uh-huh. Yeah.
Um, but I've been to those ones, so I want to go somewhere new.
Want to go somewhere new. Very cool. All right, got a good question from the Welch classroom, I think. How many years does it have to pass before a volcano is considered extinct?
Oh, extinct. Okay. So there's a different categories that we use for volcanoes. We normally use the words active,
Hmm.
extinct, and in the middle there's one that we call dormant.
Hmm.
So dormant is the will it do this again in the future? Maybe, maybe it will.
Hmm.
Um, extinct is a very, very difficult question. And I think those boundaries have changed and different people use different things. Um, you might look back at a volcano and see how many times it's erupted in the past. So if
Hmm.
you have an idea of what year or how far back in time those volcanoes have erupted, say you have a volcano that has erupted every 100 years for several thousand years, but
Hmm.
it's not erupted in 10,000 years. Is it maybe extinct? It's a really difficult question. So normally we would use timescales, I think, of hundreds of thousands to millions of years to give extinct. But if we use the islands of Hawaii as an example, so the big island of Hawaii has five volcanoes on it. Two of them are modern active, so that's Kilauea and Mauna Loa.
Hmm.
Mauna Kea, which is the other big peak, um, is still considered a dormant volcano. So it's not erupted for some time, but it's anticipated it will erupt at some point in the future. But if you go back along the Hawaiian Islands, over to Maui, over to Oahu, over to Kauai, those volcanoes haven't erupted for a few million years. But the Hawaiian Islands actually have some bits of volcanoes that have erupted in the last 100,000. So
Hmm.
Diamond Head, which is a
Yeah.
very, very popular spot on
Hmm.
Oahu and near Honolulu, only erupted within the last 100,000 years,
Hmm.
even though that island was formed a few million years ago. So
Right.
volcanoes can have like these pulses, like a few millions of years in the future. So it's really difficult to like clearly say this volcano is extinct.
Cool.
And that's why we have volcanologists.
Right. Yeah. Don't count these volcanoes out. That's what
Yeah.
I've learned today. Um, oh my gosh, I had a question that I couldn't remember. Oh, can you collect lava or is it too hot to collect?
Oh, let me go back to a slide and then if we can share this slide just for a second.
Sure.
Let me go back to it. There it is. Okay. In fact, it'll be easiest to share just that screen. So basically, the bottom line is, yes, you absolutely can. You absolutely can sample lava. So in the top right-hand corner of this slide that you see here,
Hmm.
there is a volcanologist working on Hawaii, and all they have is a thin metal glove, or a special glove, a heat glove, and they're basically using a rock hammer to stick the hammer inside the lava. So you see that red part of the lava.
Uh-huh.
And there's a really high-tech piece of equipment just in front of the scientist, and that is a metal bucket. And that metal bucket is filled with cold water. So
Huh.
what the volcanologist will be doing is carefully sticking this hammer inside the lava, breaking it apart to get under the thin crust, getting the hot bit of the lava, and then immediately putting that molten rock into the water so it cools instantly. When you have something hot that meets something cold, it essentially freezes. So you're
Uh-huh.
freezing the lava into a solid piece of rock. And that's actually one of the best ways to sample lavas in the field, is literally, it's not high tech, it's wear some protective equipment, have something that is far away. You can't do it by hand, so a long hammer and a bucket of water.
Wow.
But
Okay, then
don't do this at home. Let the professionals do it.
no chance. I'm not going anywhere near that for sure. When you like crack the top, like how much are we talking like creme brulee, egg? Like how much? how crunchy are we talking?
It depends how long it's been sat there cooling. So a lava flow like that might still stay molten in its inside for some hours, maybe days. The thicker a lava flow gets, the
Uh-huh.
longer it takes to cool down. So a
Right.
thin lava flow would cool quite quickly, but a thick one. So that one you see in the picture there might take a couple of hours, maybe up to a day to cool down in its center. And so the top, even though it's a solid crust, lava starts to cool into a solid around 400, 500 degrees Celsius, so maybe 1,000 degrees Fahrenheit.
Hmm.
Something, yeah, about 900,000 degrees Fahrenheit. Um, but it's actually very easy to break that crust apart. It's more like the skin on the top of like hot milk.
Oh, so really, really thin. Wow,
Yeah,
cool.
yeah, it doesn't take a lot to break through it unless it's been sat. If it's fresh
For a
lava
while.
like that, you're basically pushing it straight in. It's almost like it's got the consistency of like squeezy dough, play dough.
Uh-huh. Yeah. Whoa, cool. Rylan rather would like to know, oh, how do volcanoes erupt? I think we probably covered.
Yeah, if you want a quick reminder of
Let's
that,
do like, yeah,
the
like the
the
simplest
the
version.
yeah, a bottle of Coca-Cola. Essentially, volcanoes are full of magma. Magma is a mixture of solid crystals, molten rock, but also gas. And it's the
Mhm.
gas that drives the eruption. So if you take a bottle of Coke, give it a shake up, and when you open that cap, the pressure is released and the bubbles come out. And that's essentially how a volcano works.
Awesome. I just realized that we went over time because I was asking you too many questions about
That's all
volcanoes.
good.
Whoops. So I'm going to ask you the final two questions that we ask everybody. The first
Okay.
is if you had everyone's attention in the whole world and you could ask or you could tell them one thing about your area of expertise or from within your area of expertise, what would that be?
Um, that we should learn to love what volcanoes give us, and that we should have a healthy fear of
Mhm.
something that is dangerous, but we should learn to appreciate how incredible these things are, and also how beautiful our land and nature is because of volcanoes and of lava.
Very cool. All right, and our final question. You still have everybody's attention in the world. You can tell them one thing about anything. This could be significant, it could be silly, it could be truly whatever you want. What do you need everyone in the world, regardless of the subject, to know?
What do I need everybody to know? Um, Oh my goodness. That
It's hard.
yeah, that has thrown me a complete curveball. I'm even just looking in my screen at what's behind me for sources of
Uh-huh.
inspiration. Oh, here we go. Uh we're looking out to the stars a lot for source of exploration and new discoveries. But I mean, you're gonna love this one, Sarah. The bottom of the ocean
Yeah,
is our true frontier,
yeah,
I think, of exploration. And people may say that, that back in history was when all the explorers were out there exploring new regions of our planet. We still have so far to go. We've only
absolutely.
mapped a quarter of our seafloor. We've seen less than a tiny fraction of 1% on camera. Let's look in the oceans.
I'm on board with that.
Yeah,
Co-signed by the squid biologist.
just 2 days ago, one of the organizations announced over 800 new species discovered in our oceans, and
Yeah,
that was just one organization.
right. Yeah.
So yeah, deep ocean, folks, exploration
So
and discovery.
that's right. That's right. Amazing. Okay. Do you have anything you'd like to plug that we should know about, how we can follow up with you on social media?
Yeah, absolutely. So my platforms are all under the similar sort of handle. So my name's Sam Mitchell. So if you do S Mitchell and underscore science, basically all of my social media channels are through there. So Instagram, TikTok, YouTube, Blue Sky, and likewise I also have a website, Mitchell Science, smitchellscience.com.
Awesome. Thank you
Yep.
so much for taking the time.
No problem at all. Thank you so much for having me.
It's really great. Everybody, our next session will be next month. You can go to skypeascientist.com, click the live streams, and get all the RSVP links for that. Next month, we're talking about space. The month after, we're talking about shrimp. So hope to see you there. Thank you, Ramona, for interpreting for us. We appreciate you.
Thank you
Um,
so much.
yes, and thank you all for coming. We'll see you next month. Bye.